Hello everyone, I am Dr. Tanmay Vishwas. I welcome you all in my channel Chemistry: The Mystery of Molecules. Today's topic of discussion is very interesting topic: deep sea mining. Is it really an opportunity or an environmental disaster? We'll learn a lot of knowledge on this video. So this is actually a kind of mega project on International Ocean Board. But before going to the main topic, one MCQ for you. What is the specific gravity of water at 25 degrees centigrade? I request everyone to attempt this question into the comment box, and don't worry, at the end of the discussion we'll have the right answer. So let's go to the main topic. What is deep sea mining? It says deep sea mining is actually a project of retrieving mineral deposit from ocean below 200 meters, the deep sea bed. So these actually covers the 2/3 of the total sea floor. It is a massive area we are talking now. So if you look at where the exploration are possible, actually based on this map you can see there are polymetallic nodules, cobalt rich ferromanganese crust or polymetallic sulfides are available on wide range of sea floor. But if you look at this Clarion Krypton zone into the Pacific Ocean, this is actually main the point of interest. Lots of things are discussed on the mining at this region. Now, the most important question, how to extract those reserves. Now, if you look at this diagram, you can see how the deep sea mining is done. So there is one actually a vessel here. From this vessel through where, so one rover is sent on the sea floor. And you can see there are this polymetallic nodules. So actually this rover moves on the sea floor, it collects these nodules and it sent back to the main vessel, where this vessel keep the important nodules and whatever rest of the things, dust, etc., it again throws inside the water. Now, so you can understand that what could be the problem. Actually here there is no digging. So whatever these nodules are here, so those are collected by this rover. So this is the overall project. Now the most important question here, why do we need the deep sea mining? Simple answer, to extract resources like cobalt, nickel, manganese. Why? Because they could be utilized in lithium-ion battery, and this lithium-ion battery is essential for transition from fossil fuel-based energy to renewable energy or clean energy. Remember, supply of clean energy is not regular. So sometimes it produces huge amounts, sometimes less. So in order to maintain a particular energy density on the grid, so we need to store the energy. But the most important use of lithium ion battery comes in the transport sector. So in order to decarbonize the transport sector, we need huge amount of lithium ion battery. For that purpose, these metals are needed. Now if you look at the World Bank's report, that the production of such minerals such as graphite, lithium, cobalt, such kind of metals will increase nearly 500% in the 2050. So nearly 25 years, 500% jump. So this much demand increase. So how to fulfill the demand? Do we have enough resources on our land? Actually, answer is very confusing, because if you look at the land-based reserve, they are also located in some plant most bioactive reserves, including like Indonesia, Democratic Republic of Congo and South Africa, etc. zones. So these zones are also ecologically fragile, but it is essential to find alternate reserve to ensure constant supply. Otherwise, we shall not be able to meet up our renewable energy goal, and we may not be able to save our planet from global warming, temperature rise less than 2 degrees, like Paris Climate Agreement target. Now, what are those polymetallic nodules? These polymetallic nodules are like manganese, cobalt, copper, etc. You can look at their uses. For example, manganese is utilized extensively in steel making, cobalt for rechargeable battery. Actually, lithium cobaltate is used in lithium ion battery. Copper for electrical wire, nickel for wind turbines. Lots of more other uses are there also. Now, can't we meet this demand by recycling? Because very often we say that okay, reduce, reuse and recycle. Can't we do this? Only 10%. So by recycling we can meet the demand at 2040 by only 10%, told by International Energy Agency. So from where we want that remaining 90%? So we need to extract, we need to find some new resources, we need some additional resources. Otherwise there will be a demand versus supply gap of such metals, because if we want to shift from to renewable, we need, so demand will increase, but supply is not, so consequently there will be an increase in price. And now if the increased price goes beyond the affordable range of common people, then the main target, for example, petroleum based car to battery cars, could not be achieved. So whatever the main target to reduce the climate change, reduce the global temperature rise less than 2 degrees centigrade, it will be very difficult to achieve. Now the main concern about deep sea mining is about the environmental. So before going to that, we need to know how much knowledge do we really have about deep sea. So actually it is really surprising. We do not have enough knowledge. Deep sea over 75%, the seafloor floor remain unmapped, we don't know, and less than 1% of the deep ocean has been explored. So from these data we can say majority of part of our oceans floor we do not know. Even there is a surprising word that we know more moon's surface compared to our ocean surface. So we need more knowledge, because if we want to know the environmental concern about deep sea mining, then we need to know it. Actually, if you look at the impact on environment, that is, it may destroy the ecology of local zone. Why? Because the waste produced at that area, you can see here, after this work done, so it releases some amount of waste pollutant. So whatever release, so that can damage the area irreversibly. I repeat the word irreversibly, means once it is destroyed, it cannot be reversed back. Irreversible in the ecosystem. So it's a really concerning thing. Not only that, sound pollution like noise, light pollution, etc. can hamper the species. For example, here these dolphins, whales, they communicate through ultrasound, so their communication will be disturbed. Not only that, the toxic waste or byproduct metal can enter into the food chain. For example, whatever these metals are released, cobalt, copper, they are toxic transition metals. So they are spread. Now they can flow through the ocean current to long distance. Not only that, they could be absorbed by ocean plants or ocean small animals. Later on, they will be consumed by the fishes, etc. And we consume fish or other seafood, so that will be ended up inside our body, resulting metal toxicity. Now you may ask one question: they were previously there on the sea floor, so that time doesn't they dissolve? No, because whatever nodules are there, those are insoluble in water. They have a nature's own strategy to preserve them this place. But whenever we are doing some kind of processing and releasing them, so small particles are produced, and the chance of them getting mixed with the water or dissolved increases. They are significantly toxic, that small amount of their presence can hamper a lot. Not only that, some kind of nodules are also shelter for some animals, so they utilize this shelter for their hiding, their hunting, etc. So these nodules has important contribution in local ecology too. So if you take out these nodules, those species dependent on their survival on this, they may be endangered. So this is a really concerning thing. Now you may ask one question, that is there any experimental proof regarding the deep sea mining previously? Then we can conclude easily. So actually there is an experimental project done in the Peru Basin at 1895, 10.8 square kilometers sea area. Experiment was done. Thus, to study the environmental impact of small scale sediment disturbance, means such kind of sediment disturbance thing they have done, and carbon based food web model collected the data 2015. So it's a 26-year of overall study. What happened? So here what is observed, that this find signals that after 26 year also the site did not recover. So actually there is a damage present even after 26 years. So this is a really dangerous sign and concerning data. So now you will ask that, sir, is it really worthy to take a risk to the marine ecosystem? or what potential loss we may encounter in case of any catastrophe. So whatever mainly we are talking, that is risk versus gain in this deep sea mining project. So based on my understanding, I can say that before touching the seabed for the mining, we need to do lots of study on this, and we need to discuss this issue publicly, because if there is benefit, people will get; if there is a danger, people will face the consequence. So open discussion should be done in presence of common people, scientists, engineer, as well as industry people, such that everyone can provide their opinion. Actually, if you look at global population, that our global population till now increasing. Right now we have a 8 billion population, and it is predicted that it may reach up to 10 billion, then it will decline. So more food needed for more people, and actually oceans are major source for food. For example, non-vegetarian food like fish, prawns, octopus, etc. Vegetarian food like kelp. So we are producing, or we are collecting huge amount of seafood from this ocean. So if we end up toxicating this ocean, then our food may end up to be toxic. So we should not end up toxic seafood, because food security more essential compared to energy security. So actually, due to the human activity, coastal region are already polluted enough significantly, and now we are approaching towards the deep sea. And in this context, my personal opinion is that we have polluted the planet too much. Before taking any major step, significant amount of discussion needed. Now I will say that, sir, okay, this is a big problem. How can we manage this? We need those solutions for global warming and climate change. We need those kind of elements. Simple answer from my side: lots of research, exploration, discussion needed, because science is the only solution in any obstacles. So we need to do lots of research and discussion and sharing data among the countries, such that it could be resolved as soon as possible. Remember, once the ecosystem is destroyed, it is very difficult to restore the damage, and we have to live in this planet. It is not that we'll pollute and leave this planet and will migrate to some other planets. No. So before making any big step, lots of study is essential. Now this is the overall discussion. Let's go to the MCQ. What is the specific gravity of ocean water at 25 degrees centigrade? It is higher than 1. So it is actually nearly 1.025 gram per cc at 25 degrees centigrade. Now if you look at pure water, its specific gravity nearly or equals 1. If you ask me that why the specific gravity of ocean is higher than pure water, this is because in ocean water huge amount of salt, sodium chloride, is dissolved. So because of the presence of this extra salt, it is really huge amount of energy you need to supply to the ocean water to increase its temperature 1 degree centigrade, and specific gravity is higher. And that's why this ocean water acts as a reservoir for heat. Even I have already discussed a dedicated lecture on ocean warming, so it is a really concerning issue. So this is the overall discussion. There are the references of this video. If you want, you may go through them. But before ending up this video, I have a request to you that please write your opinion in the comment box. What do you think? It is not a country-based issue, it's a global issue. So we should discuss a lot about this. Please write your opinion. Are you in favor? Are you against? Or do you have some another opinion? Please write in the comment box. I'd be very happy to know your opinion. So thanks for watching. See you in my next video. Bye bye.